Singularity.
My name is Nicola, aka Socrates, and you're watching Singularity One-on-One. Singularity One-on-One is a regular podcast of Singularity weblog, where you can go and listen to it or download it in full. If you guys enjoyed the show, you can help me make it better by liking this video, writing a review on iTunes, leaving a comment on the blog, or simply making a donation. As always, I will be the man with the questions, and today, the man with the answers is Tad Starner. Tad is a wearable computing pioneer who coined the term augmented reality. He's also a professor at Georgia Institute of Technology and a technical lead on Google's Glass, a self-contained wearable computer. Tad, I'm so excited to have you on my show.
Thank you very much.
Fantastic. So I know you're very busy, so let's just jump right in. So if you were to introduce yourself in a couple of sentences, how would you do that?
Well, I'm one of the founders of the field of wearable computing, and I do a lot of research in mobile HCI. In particular, I'm a professor at the Georgia Institute of Technology. I'm also on the technical leads and managers on Google's Glass. I've been doing wearable computing part of my daily life for the past 20 years. It's been an everyday part of my daily life since 1993, and to my knowledge, it's the longest experience out there.
That's absolutely amazing. Perhaps you can share with us the story about how you coined the term augmented reality?
Well, so I was a undergraduate and was very interested in working in the field. I had seen, some science fiction movies about having graphics and text overlay your visual field. And so I looked into this, and the term that was used at the time was artificial reality. Ryan Kruger had this great book called Artificial Reality 2. Unfortunately, the term had been sort of purloined by Timothy Leary and Jaron Lanier and when they were starting talking about VR and if you actually searched on the term, you'd end up seeing about LSD drug trips. So what I needed to do was find a new term that when I put in for a fellowship to actually work in the field with the Department of Defense, it wouldn't come up with something that they might react poorly to. So I thought about it for a while and came up with the term augmented reality because that seemed to be close and really got the right feeling to what I wanted to do. I wanted to augment what you were seeing in the real world. Fortunately, there are other people out there doing the same, had the same idea. I think Tom Claudel and David Mizell at Boeing working on using augmented reality to help put together wiring harnesses for Boeing aircraft. And they started publishing their stuff about 92. I think they started talking about it, but apparently they were also using the term about the same time I was. And that what really got the term solid was when Steve Feiner started using it to describe his work in 93 and 92 when they were doing work, academic publications on it.
I see. And just for the sake of our conversation, perhaps you can tell us the exact definition. What do you mean when you say augmented reality?
For me, augmented reality was just meant having computer information with you at the right time and place. For me, having a text that says, you are in Union Square in San Francisco, or having something that says, this is the TSRB building at Georgia Tech. These things are examples of augmented reality, and that's loosely coupled. I did not necessarily mean to be precise registration at the time. However, in the field now, augmented reality, as in academic terms, often means the registered version. For me, though, having your spot on a map on the display is augmented reality. Having a list of the restaurants that are nearby to you is augmented reality. Basically, having stuff that's with you in a mobile environment such that you can actually walk around and in a free manner have the information with you. That, to me, is augmented reality.
Mm-hmm. Let me try and see if we can differentiate the concept of augmented reality with another kind of computing that you've been associated with from the very early days of it, which is wearable computing. So what is wearable computing and how is it different from augmented reality?
Well, wearable computing is basically anything where you have a computing on the body and a system designed to be used while you're doing other things. In my definition, an MP3 player is a pretty good example of a wearable computer, because you can use it while you're walking on the street or doing some other task. It's on your body, and it's designed to be a secondary interface, something you're using while you're doing other things.
Mm-hmm.
So that's one of the interesting things about wearable computing. In the early days, people were looking at for maintenance, inspection, repair, that sort of stuff. But one of my big contributions to the field is that I started to systematically investigate and articulate why you want to have wearable computers in your daily life. And that's one of the reasons why I really pushed to found the field with my friends at Carnegie Mellon and Georgia Tech at the time, is that I thought that there was going to be this convergence of technology on the body. Nicholas Negroponte used to talk about how the PC was going to have this convergence of everything in your home. For example, he said, eventually your PC is going to be your VCR, your telephone, your fax machine. It's going to do your email. It's going to be your video editing. And he was right. And this was in the early 90s. And I was saying, well, look, we're going to have the same sort of convergence on the body. This thing's going to become your music player. It's going to become your camcorder. It's going to become your web browser, even though the web was just starting back then. It's going to basically do everything the mobile consumer electronics is going to do. Problem is, back then, nobody was really wearing a computer as part of their daily life. So I struggled to make a system in 1990 and failed. It was much too hard. Tried with a PRSA Model 100, tried with a Sun Spark station. But by 1993, I actually had a system that could be used every day, and I put one on, and I have been wearing it pretty much continuously since. So, and that's the longest experience that I know of out there. But what was great is that I got a lot of other students involved. So people like Brad Rose and Lenny Foner and Rich Duvall. And so we founded this thing called the Wearable Computing Project, and about 1995. And Steve Mann actually joined it, started wearing a machine continuously starting about 1995 as well. Mm-hmm. But we had enough people to actually show how you'd actually use these devices as a group.
So is there some overlap between wearable computing and augmented reality? Let's take, for example, Google Glass. Mm-hmm. Is that wearable computing or is it augmented reality?
Well, I think it's both. It's certainly a wearable computer in that it's something you wear on your body and it's off and you use it while doing other things. It's augmented reality in that, you can see your spot on a map and you can get turn-by-turn directions from a first-person viewpoint, right? That's pretty compelling stuff. As you turn your head, it actually it changes the map to see where you're going. It also can give you information based on your location. So, to me, it's both.
And now, a few weeks ago, I interviewed Ori Inbar, and he said that as far as he knows, he wouldn't really call Google Glass augmented reality at this point, because it doesn't have, in his opinion, the overlay over the reality. In other words, you have to sort of take your gaze off the reality in front of you and lift it up to focus on the screen of Google Glass. So in the moment that you're looking at Glass, you're not looking at anything else and vice versa. So there's not that overlay.
Well, that's not quite true. So if I do this, right, I have the time and I can actually see through it to your face, right? It's a transparent display. So if you're talking about whether or not you can see both the screen and the real world at the same time, well, you can. So by that definition, it certainly is augmented reality. If you're talking about overlay, no, you're not doing overlay with it. You're not doing precise registered, I shouldn't say that. You are doing overlay with it. You're not doing precisely registered graphics, right? Now, if you're talking about something that tracks your movement and how you're turning your head, well, it does do that because you're doing turn-by-turn directions as you walk down the street in a city, and it actually rearranges its perspective depending on where you are. So, for me, augmented reality is a spectrum. It really has to do with the amount of registration you have, as to, how much, people generally think about. For me, though, I think anything with this sort of overlay, anything that actually provides this information while you're on the go, that to me really does count as augmented reality.
Mm-hmm. Now, before we jump into some more questions about Google Glass, I want to sort of roll back the tape of time and go early in your days when you actually got first to be interested in wearable computing, in augmented reality, and ask you why?
Why?
And how? I mean, in the 1980s, that was very fringe, kind of very beyond geeky, I would say. It was absolutely unique. How in the world did you get to do this?
Well, what happened was I was a student at MIT, and I was paying $20,000 a year for my education. At that time, that was a rather large sum of money. And I found that I could go to class, and by the time next month rolled around, I didn't really remember anything from class. So I tried to take good notes, and I found that either I could concentrate well and take good notes, but then I'd never get an intuition for what the professor was saying. So when I did the other thing, when I just didn't take notes and got an intuition of what the professor was saying and put all my attention there, then I could get that intuition, but within 2 hours I'd forget it. So I really wanted a system that I could both attend the lecture, get a good intuition, and get good notes. But the problem was that, every time I tried to write, it was too slow. I couldn't write fast enough. So I switched to a laptop computer. It was this TRS-80 Model 100 device I had, and it turned out that was also too slow. Even though I could type very quickly, there's something about it where I don't know, looking between the computer screen and the blackboard, for some reason I really wasn't getting where I was hoping. So then I said, okay, well, let me try something different. Let me try a heads-up display. So a friend of mine lent me his display that he was working on, and I had a one-hand keyboard, something called a twiddler, which I have here. And I found that having the display up in a heads-up manner, and I could put the focus display at the same depth as the blackboard of the professor in front of me. Mm-hmm. And I could, with this keyboard, I could type up to 130 words per minute. So suddenly, wow. I can burst to 130, I sustain about 70. So wow. What was interesting is that now I could take really excellent book quality formatted notes and still get the intuition. And a light bulb went off in my head, and I said, hey, look, this is really compelling. This really allows me to become a better student. But I was also doing research at the time. And what I realized is that having this mobile system, something I made for the classroom originally, really allowed me to take better notes in person. If I ran across a grad student or a professor, I might have 30 seconds in the hallway, and they might say something I want to remember, but by the time I got back to some place I could write it down, I forget it. For example, the first time I used my wearable computer in a hallway conversation, it was with a guy by the name of Trevor Darrell. I remember asking him, so how do I actually recover this data from backup tape? And he said, well, it's pretty easy. Just go to the Sun, 110 and say, type in tar-xvzf/dev/nrst1. And I typed it in real quick and I had it. But previously, you can imagine by the time you get from the hallway back to the computer, you've forgotten that really complex statement. So I suddenly realized that, what I could do is use this in my daily communication with people. And suddenly I became a much better researcher. I had the ability to remember things, from day to day and actually use it in my daily conversation. And what really, the first things we did is something called the Remembrance Agent. You can still see this at remem.org. A friend of mine, Brad Rhodes, put this out. And it's one of the first pieces of software I wrote for my wearable computer. And what it does is it looks to see what you're typing and then pulls up things that are relevant to the current text. So that means that if I'm talking with you about, say, electronic noses, it pulls up a file from the founder of Cyrano, a company that did electronic noses, where I had an extensive discussion with him, and suddenly it's like I'm a world expert on it. Right? Suddenly I have that information in front of me, and I can really recall this information very well. And suddenly it's very compelling. It's suddenly I have much more knowledge than I did just a seconds ago. It's not that I'm it's not that the computer is providing me something I don't know. It's the computer is reminding me of stuff that I've sort of forgotten, but now just a little bit of hint, and all that stuff kind of comes flooding back into my natural memory, and then it kind of, reloads, so to speak. And the remembrance agent, we actually did this at Georgia Tech. We made it so that as you were speaking with somebody, it changed the voice to text, and then just typed it in your text buffer, and then that pulled up memories from your past that might be relevant to the conversation. I remember one of the coolest things. So for me, all this stuff was about three things: augmented memory, augmented reality, and what I used to call intellectual collectives. And with the augmented memory stuff, that was the first thing I really found compelling, and yet, we're still not seeing that much of it in the wearable computing community yet. One of my augmented reality was sort of the obvious thing of doing the computer overlay, right, with it. And so we had some early papers on that. And that seems to be, have gone to be very much out there now. A lot of people do work in augmented reality. The intellectual collectives thing was a little bit more interesting. It's sort of like what social networks do, but it's much more real time. So I'll give you an example. When I go to a panel, I will often have people remotely helping me out. So I was recently testifying in front of the National Academies of Science, and I had a panel of people in front of me, and I brought my lab with me. Even though I was in California and my lab was in Atlanta, I had a little camera on my shoulder and a little microphone. They knew I was going to do this, and what I did is I had my presentation on the screen. Then I also had a screen that showed people what was on my wearable computer at the same time. And so as I'm going through the presentation, it was a very loose format. These panel members would ask me questions as we went. I would answer it, but also all my grad students would be throwing me, suggested things to say, throwing up URLs, pulling up web pages in my screen so I could actually, see what it was they're talking about. And, allowed me to become much more, an expert than I was, having these other people listening in, helping me out. And, pretty soon, because I was explicitly showing that to the panel, they were starting to ask more questions about what my students were typing than what was on my presentation. And they found the whole process fascinating. Another version of the intellectual collectives is I told you about the remembrance agent, right? And when you have one of these keyboards and one of these displays, you tend to type everything. You take notes on all your conversations. You take notes on everything you find compelling, just so you have this augmented memory. What happens when you give those notes to somebody else? So three guys, Brad Rose, David Kaplowitz, and myself, shared our notes. And what was cool is that suddenly we had these shadow memories of each other. Brad Rose was my roommate, as well as my fellow worker on wearable computing at the time. And so a lot of things, were similar between the two of us. However, every once in a while I'd be talking to somebody and typing in notes, and suddenly this memory would come up. And I'd say, oh, I remember that hold it, that's Brad's memory, not mine. And then one day, I was talking to British Telecom, I think it was, and they asked the question on, some obscure question on power, on self-generating power using wearable computers. And, I had answered the question. I wrote down a detailed answer just for the next time somebody asked it. And I was in Brad's lab, and I was hiding away. I was actually working my PhD thesis at the time and trying to hide from everybody. And I heard Brad give a demo to Hewlett-Packard, HP. And they asked something about wearable computing power, and Brad says, well, actually, I don't know the answer to that, but hold on a second, Thad does. And he pulls up this paragraph I'd written before and starts reading it to them, right? Suddenly, Brad is channeling what I had just written, the previous week. And I was all ready to get up and go introduce myself when I was sitting there with my jaw on the floor, and how seamlessly Brad could integrate this. I mean, he didn't actually just read the paragraph. He actually talked about it as if it was his own, right? If it was his own memory, his own authorship. He was able to, incorporate that information so well because we worked together so closely. he could integrate those memories so well that he really could own that information. And I found that very compelling. It's the first time the first time for me, we actually got the system, so that, all these memories are kind of seamlessly shared across people, and it was passive, right? It wasn't something you activated, it was passive. And that was so exciting to me.
That's absolutely amazing. Let me ask you this though. So basically, one of the things that this allows you is to multitask, take notes, pay attention, listen to the professor, get tips or notes or references from your students all at the same time. Do you not get confused from multiple inputs like this?
Yeah,
and how can you process all of them at once?
So I'm actually very bad at multitasking. It might seem ironic, but I really am. You can test me. It's true. What happens is if you actually do stuff where it's different subjects, like if I was trying to read my email right now while talking to you, I would sound like an idiot. You just really can't keep those two separate things going on at the same time. However, when you actually have something where it's the same subject, like where you are taking notes as somebody is talking and writing on the blackboard, that works just fine. Matter of fact, it actually focuses your attention, and I found this really compelling. I used to fall asleep all the time in lecture. I would used to daydream, and that's part of the reason why I couldn't take good notes. But having the wearable computer where I'm taking notes on my heads-up screen, I'm not paying attention to what I type because I'm touch typing with the keyboard, but it allowed me to really devote all my attention to what that person was saying. And when I get a cool idea or something based on what somebody was saying, I'd write it down quick so I'd remember it. And then I could go on, get back to what I was doing. That's really, that was really compelling for me. As a matter of fact, one of the things that would happen when you get people with these displays and keyboards together is we'd have these much deeper research conversations. What happens is all of us evolved the system for outlining our thoughts, outlining the conversation. We take these careful notes, but we also outline the future conversation. If we were saying something and wanted to say something in the future, based on what the other person was, the other person's topic at the time, we wouldn't interrupt. We'd actually write down that topic, above the current timeline, and then get back to it later. So that allowed us to explore one topic deeply, and then pop back up to the top and explore another topic again. And so those conversations tend to be much more, much deeper, much more exploratory, and you're not constantly bursting out with these new ideas before you forget them because they'll always be there. They're always in front of your eyeball.
Mm-hmm. Tad, let me ask you now a few questions about Google Glass. Let me start like this. What's the most fundamental misrepresentation or confusion about Google Glass that you tend to see a lot and that you really want to correct?
Well, part of it is the fact that people don't think you can tell when it's on. Well, it's very easy. For example, that's it off. It's very clear. You can see it. It's dim. And actually, I probably can show it to the camera here. So that's it off. That's it on. Right? It's very clear. Now, also so you can actually see me go through email here, go through SMSs, go through some pictures, that sort of stuff. So, it's, whenever somebody uses it, you can kind of see what they're doing. That includes things like, okay, Glass, take a picture. Right? You can actually see that I took a picture. And so in many senses, having a transparent screen sort of gives other people in your environment social cues. And that really allows them to participate in the interaction. And I think that's a wise thing. So, people's, misunderstandings of how Glass looks and how it works, I think, as soon as they see somebody use it like that, they get a much better idea of how it's going to be used and why you would use it.
Mm-hmm. If you were to describe what Google Glass is and what Google Glass does to a totally sort of technology agnostic person, how would you do that?
Well, I think Larry Page said it best. Google Glass reduces the time between intention and action. Reduces the time between when you first want to do something and when you can actually execute it. For example, career batting average of Mickey Mantle. So in that case, I had the intention of actually doing a web search, and I could do it that quickly and get an answer back saying 0.298. Right?
Wow.
So between my first thought of, I want to know this information, and having it from my eyeballs, it's literally seconds. And that's what glass can do that other devices can't. Same thing with, as I get, say, SMSs in. This morning you sent me an SMS from the lobby saying you were there. And so I could, I heard Bing, and I looked up, it turns on the display, shows me your SMS. And then I could just tap and reply and say, okay, I'll be down in a few seconds. Mm-hmm. And between the getting the Bing that tells me there's a notification, the intention of looking at the notification, it's just a split second, it's looking up. Suddenly I can see what the notification was. I could have ignored it, I could have been busy, but, I chose to look at it, and then wanting to reply. All that interaction was literally seconds. And that is something you can't do on any other device right now.
Mm-hmm. I don't want to go into the specifics of the technical specs of the device. I think those can be found elsewhere.
They can be found on the web pages,
internet.
Yes.
Yeah, we have, I think, more important issues to discuss. But if you were to grab just one spec that's really amazing, and it took really almost or perhaps a breakthrough to make it real, which one is that in your mind?
45 grams, the weight. I am wearing the equivalent of a Cray XMP supercomputer on my head. This is a wearable supercomputer. That is ridiculous, right? The amount of power I have on my face right now in such a lightweight thing is more than the first 10 machines I made in wearable computers combined.
At 45 grams.
At 45 grams. And the thing is, you wear it all day. You put this thing, this one's my glasses, but before I was wearing my glasses and glass on top of it, I still wore it all day because it was so comfortable. It didn't feel like anything. The nose weight is very little. It's balanced well across the ear. Our design people have been so good at now making this thing comfortable and making it usable and making it so that, you can see the display quickly. But that 45 grams, that is such a breakthrough. I don't know of anything else out there in that sort of, that has this sort of power, in that sort of weight.
Mm-hmm. Now, what are your favorite apps that you use most often?
It may seem unexciting, but it's things like SMS and email and the clock, right? I mean, it's the stuff that you do in your daily life. I mean, I get, all my important emails come up here, and what I find is that, now this might seem strange, but, I'm paid to think deeply. I'm paid to actually work on very complicated things. And so I actually will get on my laptop and turn off the network. And I will focus just on the piece of text I'm writing or the code I'm programming, whatever else it is. Because I find that all these interruptions, updates and things on my screen just draw my visual attention away and are really annoying. But I'll leave glass on. And it allows me to keep connected without being interrupted. So I'll be sitting there working on, a term of phrase, something I'm trying to articulate a particular concept, to the design team. And, I'll hear Bing, knowing that there's a important email that just came in. But I'll ignore it, right? Until I get the idea done. Cause I can't. That little Bing doesn't bother me. And then when I'm ready, I go back and I see what it was. And I go, oh, oops. My wife is outside waiting for me. I need to go. Right? But the thing is, I got down that idea. It didn't interrupt my thoughts. It didn't interrupt my flow. And so for me, having those notifications, having that subtle notification, these what we call ramping interfaces, where it just tells you there's something there, and then you can look up, get the information, and then you can read more or reply. Each stage, you are in control of your attention. And that is so much better than what's on laptops and desktops right now, where you have, mail popping up or a messenger popping up or a G Plus update or whatever else. For me, having it on the second screen whereas this is my primary work, and this is my contact with the rest of the world. Having that dichotomy allows me to do stuff, get up, look to see what I was doing with the outside world, get right back into it. Matter of fact, most of the time, if I get a notification, I'll be sitting there typing on a laptop or typing on the Twitter, and I don't even have to move my hands. Something comes in, I look up, I see it, I toss it away, I get back to what I'm doing. All that interaction is in 2 seconds, and I'm back to where I was. Didn't have any physical movement, didn't have to move my cursor on the screen. It's a surprising way to work, believe it or not, at your desktop. Right? Now, of course, when I'm out and about, it's pretty compelling too. I was talking with one of our folks at Google, and I was arriving at the Google I/O convention, and I just got off the train in San Francisco, and was walking towards the conference center, and my fellow Googler sent me an SMS saying, "Hey, there's somebody from Slate who wants to talk with you." And I said, I just tapped, I'm walking down the street. I tapped and responded. I said, "Sure, I'll be there in about 5 minutes. I'm, walking up 4th Street now." He said, "Okay." And they really want to talk about SMS. They really want to talk about productivity stuff. And I reply. We have this conversation the whole way as I'm getting to the interview. And by the time I get to the interview, I'm fully briefed on what we needed to do. That's really hard to do any other way. It's really compelling. Having this sort of ability to converse with people in micro interactions while you're doing other things. It doesn't, I'm in control of my intention. I'm walking down the street. I can know, where I can always keep my focus on the street, focus on what I'm doing. And then, get the message and look at it whenever I have a split second. It's like the dashboard of your car, right? The dashboard of your car is designed so that, you're driving and when you got a split second or a few seconds to look down and check your oil temperature or your speed or whatever else you want to look on your dashboard and look back up. Your dashboard is designed for these quick glanceable interactions. That's the same thing Glass does for you. And for me, the SMS and email part is really compelling. Having said that, I used to never take pictures. I'm one of those people, you saw in some of the presentations the other day, that there's these groups of people who take pictures all the time because it helps represent themselves. They feel like they need to promote their lives online. And there's people who actually take pictures just for memory, right? Take a picture of the whiteboard that you were working on. And then there's these people who don't take pictures. I was a guy who didn't take pictures because I didn't like living through a viewfinder. Having a camera with you all the time and trying to line things up and be finicky, you weren't living your life. You were photographing your life. You were videoing your life. Mm-hmm. And for me, I didn't want to live that way. And so I didn't carry cameras. However, now because taking a picture is that fast, right? I take pictures all the time. So suddenly I went from, I think in this past year, I have more pictures than I've taken in my entire life. That's saying something. And again, it's because that micro interactions, it's the ability, it's that speed to go from the intention to action. And so now, anytime I think, I might want to remember this, click. Life changing. Right there. And, I can show you this. I literally have thousands and thousands of pictures that I would never have taken before.
So it seems to me that you very strongly believe that Google Glass is a revolutionary device in a way. In a way, it would be life-changing.
I think that this device, which actually improves your life by allowing you to have these split-second interactions with support, is really compelling. I really believe this is a revolutionary device. I think Glass is a revolutionary device in that it offers something nothing else does. And it offers a suite of things. Connection with other people, through telephony, through SMS, through email. It offers, a memory aid in the form of these pictures or short little videos, these little 10-second videos it takes. It offers, little reminders on your next calendar appointment, or, it even suggests places to eat, places to see nearby. These sorts of things are really change how you interact with the world. And it makes you more free. It frees you up in a lot of ways from carrying all this equipment and checking your phone all the time, checking your computer, logging in all the time, it really frees you, and it really allows you to become more powerful. You keep in contact. You can keep in contact with more with so much less effort.
Mm-hmm.
So this is one of these situations where pulling the computer closer to your body is actually surprisingly liberating.
Mm-hmm. And what do you feel about, or what do you think about the sort of the pushback that's already happening in a bunch of places? For example, it's been already a few months since there was a cafe and a whole community in San Francisco that pretty much decided to ban Google Glass.
That was Seattle, but so the thing is that I do not believe anybody at that bar actually had ever seen glass. They never used it. They've never seen it used in person. So there's a lot of people who are reacting to things based on what they think it does versus what it actually does.
Mm-hmm.
So that's one of the things I like doing is, people have these preconceptions. And until they actually interact with somebody who has one or had a demo of it, they don't really quite understand what it's capable of and what it's not capable of. And when people see it, interact with it, then it kind of says, oh, well, that's kind of cool. I can see how that works. I can see how I can live with that. I can see how it actually includes others in that interaction. And then it's okay.
Let me give you another example, though.
Mm-hmm.
In the building that we just moved in with my wife probably about a month and a half or 2 months ago, I was surprised to discover that you're not allowed to take pictures anywhere or
Mm-hmm.
bring a camera anywhere in the common areas.
Mm-hmm.
That includes the lobby, the gym, the pool, anywhere.
Mm-hmm.
And I even went to the management office and started a debate on the topic, and I even send a message to the board of the directors and all that stuff. But people in this building have already decided a few years ago
Mm-hmm.
that no pictures will be allowed anywhere inside of the common areas of the building.
Okay.
Or even in the courtyard and stuff
Mm-hmm.
like that.
So that's a social contract they decide to make among themselves.
Yes.
And you're probably honoring that social contract, right?
Yes, I am.
So that's the same. So glass doesn't change that at all, right? It's, you're probably not taking out your camera phone, taking pictures of the environment. You're probably not doing interviews in the common areas. Would you actually do these interviews if you had glass? Would you actually take pictures with glass if you knew that it was, decided to be stopped by the community? No, you probably wouldn't, right? So that's the whole thing that when you design technology you want to do is you want to actually make the technology so that it helps people preserve the social contract. When I'm talking to reporters, actually, one of the first things I say is, are you recording me? And they'll say, well, no, I would tell you if I was recording you. And I respond, well, that's my point, right? There's a social contract that even as a reporter, right, even though I should have, by all respects, should expect you to be recording this, you're going to tell me first. And frankly, it's the same thing with glass.
Okay. Now, Ted, I know that you're working on a bunch of other fantastic ideas and projects. And just to name one is, for example, the mobile music touch glove. Can you share a little bit more information about that with us?
So one of the things that, remember when I said we founded the wearable computing field to investigate how these devices might be used both from a technical and from a social standpoint, we occasionally get surprises. And one of the ones that we discovered is the ability to actually teach complex mechanical tasks passively. Now, this is completely unexpected. So how this works is, suppose I want to learn the melody for Amazing Grace. I want to, pick it out on the piano. Well, normally what I do is I pull up the sheet music and, learn to read the sheet music. And then I practice it again and again, trying to get the muscle memory of that melody. Well, I can actually teach you that melody in 30 minutes while you've been doing this interview. So how this works is we take your mobile phone or pick your favorite mobile device. We download the MIDI file for Amazing Grace. And again, we're just going to do single note at a time, right-hand melody for now. And we put on this fingerless glove. And what it has is little vibrating motors at the, right below the knuckles. And as each note is played in, say, your earphones or your Bluetooth headset, it taps the finger that corresponds to that note. And you just put this thing on, and it plays the music over and over again in your ear, and you feel the tapping. And you can learn the muscle memory for that song. Now, I'm not saying anything about musicality. I'm just talking about the note sequence. And we've done this, and so, after you've done this for 30 minutes, you take off the glove, you put your hand down on the keyboard, and suddenly your hand knows what to do. It's really weird. And so I didn't believe this effect at first. When the master student who was working on it first showed me the results, I was like, that's too good. I don't believe this. Okay, let's redo this experiment. We're going to use a lot more subjects. We're going to be very controlled about it, very careful. And it worked better. We had, I don't know, something like 16 subjects, if I remember. And, half of them would just hear, they'd be introduced to the song, and they put on the glove, and the glove would go through its passive, training, passive learning. And, half the subject would just hear the notes. The other half the subject would hear the notes and feel them while they're doing a graduate entrance exam. Right?
That's unbelievable.
So they would be actually distracted. And we actually compared the results of their scores to make sure that they were the same. And so after 30 minutes, people who just heard the notes were worse than when they started, as far as being able to play something back. The ones who actually felt it on their fingers were mostly perfect. I mean, their timing wasn't the best, but their order sequence of the notes was, for I think the majority of them, correct. And we're looking at these results going, oh my word, this really works. And so we've done a lot of experiments now. Does this work while you're, say, mobile? So we have people doing scavenger hunts while learning how to play piano tunes. Does this work while you're having them do a memory task? The answer is yes, it does. Does this work while you're just watching a video, right? I gave them Star Trek Insurrection, I think, and, had them stop the movie and ask them questions about the movie, and it worked then too. So we were surprised to discover that there really is this learning effect with this tapping on the hands. The question is, what else can we do with it? So now we're looking at stenography. We're looking at stenography is kind of the obvious thing to do next. We're looking at learning how to type Braille. But one of the things that surprised us is that we had open house one day, and a colleague from the Shepherd Spinal Cord Center showed up and said, I want this for my patients. And we were like, what? Well, Debbie, why do you want this work for your patients? She says, well, I think it's actually going to help them recover sensation in their hands. Debbie, I don't understand. How would this work? Now, this is Dr. Debbie Bacchus at the Shepherd Center in Atlanta. It's one of the premier centers for traumatic spinal cord injury and brain injury. And she said, well, I think that, the brain tries to explain signals coming up to it. And if you get this tapping on the fingers, I think that my patients will happen is their brain will recruit more neurons and devote more space to it. And I'm hoping that will also cause increased sensation in the hand. And we're like, okay, we'll try this. And so we did the experiment with 10 partial spinal cord injury patients. And this was a year post-injury. So the reason why that's important is that most insurance companies don't pay for any rehabilitation services after a year, after a major injury, because generally rehab effects taper off. And so here are people, due to their injury, that should not be getting improvement, right? Or very little. And yet we gave them the gloves for 8 weeks, to learn piano. And now these people already have some mobility, some dexterity, it's a partial break. But after 8 weeks, they got significant improvement in the sensation in their hands. So much so that some were buttoning their buttons now. We had one, and that's a big deal. Dressing yourself is a big deal for independence. We had one guy, and you can see this on a CNN segment. He came in being, I believe he's a lawyer. He types on his keyboard one finger at a time. By the time he finished the 8 weeks, he was typing 4 fingers at a time. And so, of course, this is a major deal for these
changing
folks.
for those people.
We had our pilot subject came in and said, "Hey, folks, you're teaching me how to play music. Can I learn Happy Birthday?" And we said, "Sure, we'll program that up for you." And so he spent a week and, had this glove teach him Happy Birthday. And then he played it for his grandson. And that was a big emotional thing, right? And that's one of the great things about using piano learning for rehabilitation. It's not that you're doing some simple repetitive task. You're learning a new skill set, and something you might want to keep with you for the rest of your life. And we're giving you a tool that gives you superhuman learning ability for actually picking up new melodies. Mm-hmm. For our 8 weeks, they learned a new melody every week, right?
How far can we take this?
I have no idea.
I mean, can we learn to play tennis, golf, basketball, martial arts?
That's one of the reasons we're telling people about this. There's so much to do with this. The idea.
That's like a matrix kind of thing. Download almost like one step shorter.
Yeah, it's sort of the exoskeleton training system, right? And the Shepherd Center already does this for walking, but it's active attention. They'll strap you into this big exoskeleton, and the thing will actually move you, right, as you actually try to do things. But the idea you can do it passively, that we haven't seen in the literature. This idea of passive learning of these mechanical skills. And so where are the limits? We don't know. I mean, one of the things that people always ask me is, how long do you remember this? And I said, I don't know. We haven't done that experiment yet. And so, the lawyer I was telling you about, he came in to do the CNN shoot. They wanted to actually see somebody who actually had used the system. And so I had Rick come into the lab, and he was very nice to come in. He's a busy guy. He was very nice to come in, and they said, well, we'd really like to see Rick play one of the songs. It was Beethoven's Ode to Joy, right? And I was like, Rick, do you remember? It's been 6 months. And we sat him down at the piano, and he couldn't really do it. I said, let's try something. We got 10 minutes before we shoot. It'll take about 10 minutes to set up. Strap on the glove quick. I just reprogrammed it quick, put it there, and he sat there. And by the time they were ready, he's playing the full Beethoven's Ode to Joy perfectly. It's like just a little bit of extra learning again. Refresh that stuff he learned 6 months ago. And my jaw's on the floor, right? It's like, wow, I didn't expect that. So, I mean, that's not formal. It's completely anecdotal. I have no idea if that would hold up in formal testing. But it's really suggestive, mm-hmm. right? So, when we were first submitting a paper on this, we had a reviewer who said, and I love, it's one of the best reviews I ever got back, I was prepared to hate this paper. Because obviously you guys don't know anything about active learning with haptics. Here's all the references you should know, and you know what? None of them matter. Because you're doing passive stuff. And here's something you haven't done yet. If you have a musician who has repetitive stress injuries, doing that learning where you're trying to get that muscle memory is painful. It actually does more damage. If you could actually teach a musician that muscle memory so that now whenever they practice, they're focusing on the musicality, not the muscle memory, it could help them reduce the amount of injury they're doing to themselves. And we're like, oh, that's a really good application. Maybe we should try that. Mm-hmm. And so we've been very excited about, every time we talk about this to people, they come up with their own ideas on how to use it. I've been giving lots of talks about that, and hopefully we'll see other people pick up on this research and do something with it.
Now, Rick, Tad, sorry, I know your time is very valuable, but I still have about 5 or 6 questions that I want to go through because I think they're important. So I want to go quickly if we can. Let me go back to Google Glass and augmented reality a little bit more and ask you some more general questions. Like, first of all, have you read the book by Werner Vinge called Rainbow's End?
Yes, Werner is actually a member of the Wearable Computing Research mailing list. He has been since 1996.
Wow, that's absolutely amazing. That's news to me. So how impactful was that book on the way you were perceiving or working on Google?
Werner and I have been talking about this stuff for a long time. A matter of fact, he came, you remember that Werner was a computer science professor at San Diego State University. And so I've been reading his books for a while. Every time he, when he takes time off from being a professor to write a book, every time he wrote a book, he won the Hugo. If you look across real time or deepness in the sky or any of these things, he talks about this stuff, but you can actually see a clear distinction when he started joining the research list, right? So he would actually see the stuff that's coming up, right? And, was introduced to some people like Lenny Foner, who was a person who wore these computers. You can actually see Lenny, I believe, thanked in one of his books. What's wonderful is that, Werner kind of came to the lab and gave a talk on, singularity and all that. He's one of the guys who's really, established the idea of the singularity. So he's talking about these things, and he's talking about, his science fiction. I'm in the audience with my big old private eye screen, right? 1996, right? Mm-hmm. This is when we had just founded the Wearable Computing Project. So there's a few of us around, but I'm still the one who's really wearing all the time. So I'm in the audience, and you can see him look up at me, and he doesn't get it yet, right? And then we have some time afterwards, and we spend about an hour talking, where I'm saying, this is what I'm doing, this is how I'm working with it. And he says, wow, you have about 50% of the functionality I write about in my books. It's like, yes, Werner, do you want to join? So unfortunately, Werner couldn't. He has one of his eyes doesn't work well, so he can't get the fusing effect. He probably can do it with this, though. Mm-hmm. Oh no, I should ask him again. Anyways, but he joined the list, and he's been seeing the stuff ever since. And so what's great is that whenever we talk about something in research, he will take it to the next level in his books. And so oftentimes I read his books just to see, okay, here's this well-renowned science fiction author working with these concepts. Where is he taking it? Mm-hmm. And then I was just with him a few months ago. And when the Rainbow was End, one of the things I found compelling was the whole education side of it. I said, Werner, one of the things I found most disturbing as a professor was education in augmented reality. And the thing is, I couldn't actually say why your vision wouldn't work. So how'd you come up with that? What are you thinking? Have you expounded upon those ideas? And to my disappointment, Werner said, well, actually, that's the thing I spent the least amount of time thinking about. Werner, I had these high hopes that you're going to have these words of wisdom for me about how to do AR in education. And he said, yeah, sorry.
But now that you mentioned Werner, I wanted to ask you a little bit later, but what do you think of the concept of the technological singularity, which is a term that he coined in a famous paper in 1993? Yep.
So it's interesting that the same time that Werner was writing that paper, I was writing something called The Cyborgs Are Coming, where I was saying, and this was something I wrote for Wired magazine when it was first being founded. Nicholas Negroponte was one of the backers of Wired magazine. And so I sent this essay to Nicholas and to the editor, and it said, okay, here's the problem with, pen-based systems. Here's the problem with notebook computers, and here is what I've been using. This heads-up display, this one-handed keyboard. Here's this idea of augmented memory, this idea of augmented reality, this idea of intellectual collectives. Why can't this happen? Right? Here's how you make these devices. Here's the right companies. Here's the people I've talked to. I don't see why this is not a compelling vision for the future. And so that's the exact same year that Werner was writing the Singularity stuff. And as we're working on it, and as this stuff becomes more and more common, we actually got a lot of functionality that you couldn't explain to somebody in 1980. Think about it. We had, with the Wearable Computing Project, we actually had navigation. Right? You could pull up a map on your heads-up display. I remember going to Stanford for the first time, downloading the map from their website and walking around and finding my friends at Stanford who I'd never seen before, right? I remember sending messages back and forth during panel sessions. I remember doing all these activities that you now do on a smartphone and thinking this is fundamentally changing. This will fundamentally change how we live our lives. And then smartphones came out, and you can do a lot of stuff that's in the early demonstrations. If you go back to the International Symposium on Wearable Computers, the first convocation in 1997, a lot of those applications are now common on smartphones. And I was thinking, this is really world changing. And now, if you think about it, if you try to explain to somebody how you use your smartphone in 1980, they could not conceive of it. The average person in 1980, where smart cell phones are just coming out, they couldn't conceive the fact that you would never get lost again.
Yeah.
Right? They couldn't conceive about the fact that you could actually send a picture of something to other people across the planet, that you could actually share Google Hangout live from your head. Right? This stuff is something that is just inconceivable at that time. It'd be very hard to describe first of all, what it was, and then number two, why you'd find it so compelling. Why you'd find sending SMSs so compelling. And that's the definition of singularity. Right? It's where, according to what Werner was saying, it's when you just can't, it's something so fundamentally changing, you can't predict how it's going to be used. And so to me, we're living in the singularity. Right now, we are living in that transition time, whereas the people in 1980 cannot predict what this technology, you might be able to describe it to them, but you couldn't predict how it's going to affect the world. Right? So right now we are living in that singularity. We're living in the singularity of having these mobile devices that allows us to be more powerful.
But here's a fundamental, I think, clarification that I want to bring, or perhaps a response to this. I think Werner has this example of the goldfish or the flatworm. So if you explain how a cell phone, say an iPhone, works to somebody from 1980, they would understand it probably. Or do you not think that they would?
Do you think that they'd understand a smartphone? Remember, to describe to somebody let's do the following. Do turn-by-turn navigation, where it's actually responding to your head, your movements. Describe that to somebody in 1980. How would you do it?
Well, I would tell them, imagine that you have somebody sitting on your shoulder and telling you every step of the way. Go 50 paces forward, then turn right when you see this, and then turn left when you see this. Wouldn't they understand it?
But they would say, well, wouldn't that be annoying? Wouldn't that, how are you going to do that?
Well, we'd say a radio walkie-talkie, which was familiar, and imagine somebody having a camera and being able to see exactly where you are and where you're going.
That's not what you, I see, because you're talking about the voice thing. I was thinking about on the screen.
Yeah. I see where we have our differences here, because in my perception, the singularity is so fundamentally different that, as Werner says, just like a goldfish or a flatworm is unable to experience Mozart or Beethoven. I mean, they can feel some kind of vibrations, but they would never get the Ninth Symphony, right? And likewise, the difference between us and those beings that are coming post-singularity or during the singularity would be so big that fundamentally, we would be incapable of going to that level of comprehension, right?
Well, let me do your analogy with the flatworm and goldfish. I think we're splitting terms here, right? Because I'm using a very specific version of the singularity when you talk to Werner or to Ray about it.
Yeah.
But let me actually go down your path. Suppose I'm trying to do the higher end, your more fanciful thing with the flatworm or goldfish. So you're saying they can't experience Mozart, right, or symphonies. Well, why can't they? Do they not have the sensors to do it? Well, yeah, they really don't have the right ears to hear it, right? They have no cultural framework to understand it. So with the GPS systems we have now with our phones, where I can actually ask for a coffee shop nearby that serves good coffee, that has high ranked coffee. I don't have, back in 1980, I wouldn't have the ability to perceive that. I couldn't get the GPS signals. Didn't have any way to perceive it. I couldn't get the digital cell phone signals. No way to perceive that. I couldn't, so first of all, I didn't have the sensory apparatus. Now I do. So suppose you did have the sense, suppose the goldfish was equipped with our ears, right? Could understand the cultural implications of it. Okay. So back in 1980, would you understand this idea of people actually online, mobilely, actually rating things, giving Zagat reviews for the coffee shop at the corner, right?
Fair enough, yeah. I accept that we wouldn't be able to really get, even if you talk to me from 1985 or 1990 and tell me about Facebook or Twitter, I'll be like, so what? I don't get it. Twitter, 140 things. You send where and who cares and why and what's the big deal. Mm-hmm. So in that sense, I do understand what you mean. Mm-hmm. Now, do you have any advice for young people or students who are interested in this sort of emerging field of augmented reality and wearable computing that's really probably really going to take off with new devices like Google Glass?
Well, we can hope so. So the big thing is that you really need, if you have some ideas that you're passionate about, get it on your face as soon as you can, right? Get something that you're using, anything, right? Cobble together any way you can, because your ideas, your perceptions of what you're going to be using it for and how you're going to use it are probably wrong. Until you actually get something on in your everyday life, until you actually get to the stage where you can really interact with it and experience it, even the crudest manner, you probably really don't understand the problem you're trying to solve. So you got to prototype, you got to iterate, you got to interact with it and really discover what problem you're trying to solve. And that's probably the best advice I can give.
Mm-hmm. Where can people find more about you and your work?
You can find, like most academics, the best way to find out about my work is to read my papers. And so you can go to scholar.google.com and just type in my name, Thad Starner. Or if you really want to see, say, the history of wearable computing, the history of what we've been doing, just look at my academic CV. It has everything listed there. All the papers going back to the first thing we wrote out of MIT, which was the Cyborgs Are Coming paper. And then I think the next big one was Effective Computing by Roz Picard, because her first grad student was actually my office mate, Jen Healy, was working on wearable computers to sense body signals, physiological signals. A lot of the quantitative self stuff was, kind of starting around then, at least those ideas. And the last one I think was Augmented Reality through Wearable Computing, and that was probably the paper. The first version I think was 1995. That really was the first big community paper we did at the Media Lab between a lot of the cyborgs. And so if you want to find out more about the history, look there. If you want to see the mobile music touch, the papers are out there. If you want to see about our work on two-way communication with dolphins using wearable computing, the experiments we're doing with marine biologists, we have some posters up on that. So a lot of we also have a cool thing called Brain Sign, which it looks at trying to recover sign language from the motor cortex using fMRI scans, direct brain sensing of sign language. But anyways, all that stuff is up there. It's easy to find it on just by searching for the papers.
Yeah, I would say that I had almost double the amount of questions to Thad Starner that I was able to ask within this past 1 hour, because he has so many amazing sort of cutting edge projects and things that he's working on right now.
Okay.
But it's very hard to fit everything into 1 hour. So I would recommend that people follow up on that and follow the links and look into his amazing work. But I would also use it as an excuse perhaps at some point later on to ask you again for a follow-up interview.
Okay.
Now, in the meantime, though, the very last question that I always ask of my guests on the show is, if people were to take a single message from this past 1 hour with you, what would you like that to be, the most important thing that you want to send out there?
So I think the most important message is what Larry Page was saying, trying to reduce the time between intention and action. Can you use these devices like Google Glass to make yourself more powerful, more independent, to have a better life by reducing your time between your intention to do something and your ability to do it? And look for the technologies that allow you to do that, and it will really improve your life.
Reduce the time between intention and action.
Yeah.
I love that message. Thad Starner, thank you so much for being on Singularity.
Certainly, thanks for having me.